Hi, welcome to my video on the sum of the interior angles of a polygon. Sum of the interior angles of a polygon, that's a convex one. That means the diagonals are on the inside. An interior angle of a polygon is formed by two adjacent sides. So this is an interior angle right there at C, right there at B, and right there at A. Those are the interior angles of this polygon. And the polygon is ABCT, has four sides and four interior angles, T, C, B, and A. And notice that this is a polygon, PQRST, in that order. Notice you go around. You can say TSRQP, but you have to go around in whatever order. The sides are PT, PS, PQ, QR, RS, and TS. So these are the sides as I trace them out. And the interior angles are angle T, T, S, R, Q, and P. T, S, R, Q, and P. T, angle S, angle R, angle Q, and angle P. The interior angles. Now, we have a polygon listed here, The number of sides in a triangle is 3. If I draw a triangle, draw a diagonal from only one vertex, well, a triangle has no diagonals at all because all the sides of a triangle, all the segments are the sides of a triangle. So you can't draw a diagonal from non-adjacent vertices. So the number of triangles is 1, and the sum of the interior angles of this one, and this one is 180. The sum of the interior angles of a triangle is 180. A quadrilateral has 4 sides. So let's draw a quadrilateral. 4 sides, and it has 4 angles, 1, 2, 3, 4. And let's draw a diagonal from only one vertex. So let's pick this vertex and draw a diagonal. So there's only one diagonal can be drawn from this vertex. That means you have 1, 2. You have 2 triangles. It's this one and this one. So if you have 2 triangles, you have 2 times 180, which is 360 degrees in a quadrilateral. Let's do a pentagon. Pentagon has 5 sides. So 1, 2, 3, 4, 5. And if you take one vertex, let's take this one, and draw a diagonal. That's a side, so I can't do that one. So I draw that one. A diagonal is drawn from one vertex to a non-adjacent. And we draw from here over to here. That's another diagonal. I can't draw this diagonal because that's a side. So that has 2 diagonals from this vertex right here. That means you have 1, 2, 3 triangles. So that means you have 3 times 180, and that's 540. And we have a hexagon. Hexagon has 6 sides. Let's see if I can draw one with 6. 1, 2, 3, 4, 5, 6. Yep. And if I have 6 sides, let's pick a vertex. Let's pick this one. Don't make any difference which one. And I draw that diagonal, and I draw that diagonal, and I draw that diagonal. So notice that's a side. I can't draw that one or that one. So there's 3 diagonals from this same vertex. So there's 1, 2, 3, 4. There's 4 triangles. So the sum of the interior angles is 4 times 180 is 720. Check it with your calculator. Notice this is the sum of the interior angles of a triangle, 180, quadrilateral, 360, pentagon, 540, hexagon, 720. Now, what happens for any polygon? Well, there's a formula. And what happens if you notice that the number of triangles is compared to the number of sides? What do you notice? That's 3, that's 1, that's 4, that's 2, that's 5, that's 3, that's 6, that's 4. So the number of triangles is always what? 2 less than the number of sides. So the number of triangles is, if we say n is the number of sides in any polygon, then the number of triangles is always 2 less. That makes sense. 6 minus 2 is 4. 5 minus 2 is 3. Therefore, n is the number of sides in any polygon. Therefore, n minus 2 is the number of triangles. Therefore, if you take the number of triangles and multiply by 180, you will get the sum of the interior angles. So, if we want to write it like that, the formula for the sum of the interior angles of any polygon is 180 times n minus 2. I like to put the 180 in front of the n minus 2, but you don't have to. You could write down n minus 2 times 180. It's the number of triangles times 180, or that way, where n is the number of sides. So that's the formula. 180 times n minus 2. Write that formula down again. You can write down n minus 2 times 180. Or I like to put the 180 in front. When I put the 180 in front, I don't, because what happens if you go n minus 2 times 180 and you don't put the n minus 2 in brackets, then this is n minus 360. So I prefer to go 180 times n minus 2. That's just me. Examples. Find the sum of the interior angles of each. A triangle. How many? The triangle got 3 sides. So it's 180 times n minus 2. 180. And n is 3. So it's 180 times 1, which is 180. Notice that's degrees now. Quadrilateral is 4 sides. So it's 180 times n minus 2. 180 times 4 minus 2. 180 times 2, 360. Pentagon, 5 sides. So it's 180 times n minus 2. 180 times 5 minus 2. 180 times 3, and that's 5. 180 times 3, just 3 to 24 is 540. And we have, let's see how many. 1, 2, 3, 4, 5, 6, 7. We got 7 sides. So it's 180 times n minus 2. 180 times 7 minus 2. 180 times 5. And that's a 900. Let's see, just to make sure. 5 times 0 is 0. 5 eighths are 40 to 0. You can carry 4. Yep, 900. That's a hexagon. That's a heptagon. Heptagon. Remember, memorize. There's a unit on polygons. So heptagon. Here we go. Find the sum of the interior angles of each. A hexagon got 6 sides. 180 times n minus 2. 186 minus 2. 180 times 4. So that's 720. octagon has 8 sides. 180 times n minus 2. 180 times 8 minus 2. 6. 60068 48,080. And we have a decagon, which is 10 sides. Notice I write down the formula each time. When you write down the formula and substitute the number in for n, then it's easy to work out. And notice in the order of operations, I have to do the inside of the brackets first. And then I multiply 0, 8 8 is 64, so 1240 is the sum of the interior angles of a decagon. And we have 1, 2, 3, 4 sides. So it's 180 times n minus 2. 180 times 4 minus 2. And 4 minus 2, again, we have to do the inside the brackets first. So that's 360, because that's a quadrilateral. And I have memorized a triangle is 180, and a quadrilateral is 2 triangles. That's as easy as 2 times 180 is 360. But the formula, 180 degrees, remember, that's what we're talking about. So it's 180 times n minus 2, the sum of the interior angles of a polygon, of any polygon. Now let's look at a regular polygon. A regular polygon has all sides equal and all angles equal. Regular, all angles, all sides equal. So if a polygon is a triangle, it has 3 sides, so it has 3 equal angles. A hexagon is 6 sides, so it has 6 equal angles. A regular now, because all the sides are equal and all the angles are equal. A quadrilateral has 4 sides equal, so it's 4 angles equal in a regular. Octagon is 8 sides equal, 8 angles equal when it's regular. Pentagon is 5 sides equal, 5 angles equal. So the number of angles corresponds to the number of sides. That's equal. Again, if a quadrilateral got 10 sides, it's got 10 angles. If the 10 angles are equal, 10 sides are equal. Find the measure of each regular angle. Well, the formula for each regular interior. No, put the word interior there, left off the word interior. We want to find the formula. We want to find the size of the interior angle each. So the formula is the sum of the interior angles, which is, 180 times n minus 2, and it's divided by the number of angles. It makes sense. If you take all the angles, if you have the sum of all the angles, and you divide it by the number of angles that you have, then you'll have the size of each. Again, the formula, let's write it down just once more. So it's the sum, just remember this, the sum divided by the number. So what's the sum? 180 times n minus 2 divided by n. It's the sum divided by the number. Find the measure of each interior angle of a regular polygon. A triangle has 3 sides. So what's the formula? 180 times n minus 2 divided by n. So that's 180. N is 3, so I'm substituting 3n. And I work the top out first, so it's 180 times 1 divided by 3. That's 180 divided by 3, so I get a 60. So in a triangle, if all the angles are equal, 180 divided by 3 is 60. And we got an octagon, has 8 sides, so we got 180 times n minus 2 divided by n. 180 times 8 minus 2 divided by 8. And 180 times, I had to do my brackets first, 6. Now, if you didn't have a calculator, you could reduce these down. Let's see. I can divide 2 into 6 goes 3. 2 into 8 goes 4. And I can divide 4 into 180. 4 into once. 4 into 4 goes once. 480 goes 45. So 3 times 45 is 135. And if you don't like cancelling and reducing because you're multiplying, dividing here, then multiply 6 by 180 on your calculator and divide by 8 and you'll get 135. A dectagon is 10 sides, so it's 180 times n minus 2 divided by n is the formula. 180 times n minus 2 divided by n. 180 times 10 minus 2 divided by 10. And that's 180. 10 minus 2 is 8 divided by 10. And notice 10 into 10 goes once, 10 into that 180 goes 18, and 8 eighths are 64, so you get 144. Or you can take a calculator and go 180 times 8 divided by 10. But I like cancelling and reducing. So that's how I work out the interior angle. Now you practice, pause your video, and work these out. Here we go. Quadrilateral. 4 sides. Formula. 180 times n minus 2. That's the sum of the interior angles divided by the number of angles. 180 and 4 minus 2 divided by 4. So notice I substitute 4 into place of n. Done. I work out my brackets first because of PEMDAS. I have to work the inside of the brackets first in math. And I can go multiply to get 360. And I can divide by 4 to get 90. Or I can cancel. 2 into 2 goes once. 2 into 4 goes 2. 2 into 2 goes once. 2 into 180 goes 90. And 90 times 1 divided by 1 is 90. So you can multiply and divide, or you can cancel, get the answer. Number 2, 1, 2, 3, 4, 5. 5 sides. So 180 times n minus 2, the sum, divided by the number of angles. So it's 180. 5, subtract 2, divided by 5. 180. 5 minus 2 is 3. Again, a reminder, I always do the inside the brackets first, order of operations. And I can multiply that out with a calculator, or I can divide 5 into 180 goes 36, and 36 times 3 is 108. Or you can multiply 180 by 3 and divide by 5. A non-decan got 9 sides. So the formula to find the interior angle now is 180 times n minus 2 divided by n. N is 9, so it's 180. 9 minus 2 divided by 9. And we do the brackets first to get 7. And 9 is a nice number. 9 and 9 goes once. 9 and 180 goes 20. And 20 times 4 is 140. And remember a calculator. 180 times 7 divided by 9 is 140. And we got a hexagon, has 6 sides. So the formula, sum of the interior angles, 180 times n minus 2 divided by n. 180, 6 minus 2 divided by 6. So we substitute 6 into place of n. Do our brackets first by PEMDAS. And your choice, I'm going to divide 6 into 6 goes once. 6 and 180 goes 30. 30 times 4 is 120. Or if you want, you can multiply 4 times 180 to get 720. And 720 divided by 6. 6 and a 7 goes once. 6 and a 12 goes 2. So you get 120. So this is how you find the size of each interior angle of any. Notice the figure has to be regular. Key word is regular. All the angles are equal. So it's the formula is the sum divided by the number of angles. That's the sum of the interior angles, which is 180 times n minus 2 divided by n. So that's the sum of the interior angles divided by the number of angles. Memorize the formula, memorize both formulas, and it's easy to work out. Anyway, if you like my video or like what I'm doing, and if you're not a subscriber already, then click on the like button, the subscribe button, the notification bell, because there's more videos that I'll be doing, placing online. Write a comment on my video if you wish. Visit my math website, www.mathfullyexplained.com, and there you'll get information. Check out the website on me in one section, on my videos, and the strategies you're going to use to teach the math and help you learn. And the most important one is the content. That's the topics and the number of videos that are going to be on my YouTube channel. And the black font is already online, and the red font is what I'll be doing in the near future. Thank you very much. Bye-bye.